Hi everyone, welcome to the Databend June-July bi-monthly update. Over these 2 months, 3 things are especially worth highlighting. Spatial indexes have started participating in joins. The optimizer statistics module has moved to a new engine, and the lakehouse ecosystem now connects to Paimon thanks to a community contribution. Each of these 3 tracks has taken a step outward. Meanwhile, there were 80 bug fixes for correctness. In this episode, we will start with these changes. Then, we will go all the way to a real model evaluation observability pipeline. You can clearly feel that Databend has become smarter over these 2 months and also better connected to the outside world. Let's start with the numbers. From version 1.2.916 nightly to version 1.2.930 nightly, plus 2 patch releases in July. The Databend main repository shipped 15 nightly releases over these 2 months, 11 in June, 4 in July, and 2 patch releases, both in July. Breaking down the release notes, around 182 changes were merged in total. That includes 40 new features, 80 bug fixes, 33 refactors, with the rest being maintenance and CI improvements. You'll notice that fixes still make up the largest share. This also shows that stability remains a major focus for Databend. And among the new features, a few clear new directions are what really deserve a closer look in this update. Let's begin with the optimizer. To generate a good execution plan, the optimizer first needs a reliable view of data distribution. In the past, many estimates were conservative, and skewed data could easily lead to a poor join order. Over these 2 months, Databend upgraded the statistics module with a set of more modern techniques. The first is KLL Histogram, which started with an RFC and then landed in implementation. It offers a better balance between accuracy and memory usage. The second is count, means sketch a lightweight frequency estimation structure that is especially useful for identifying high-frequency values and handling data skew. The third is top, in selectivity, used to estimate selectivity for equality predicates, and it can refresh automatically as data is appended. Finally, explain can now show I/O cost during training the direct. Whether an index actually saved scan work is now visible at a glance, instead of something you have to guess. For users, most of these changes are quietly better. You do not need to change SQL for tables that have been analyzed. The optimizer simply makes more accurate decisions. Next is spatial analytics. In the last update, spatial indexes started participating in pruning. This time, they go one step further. Indexes now participate in joins. That is a meaningful change. Spatial joins such as finding points of interest that fall inside each region used to degrade into row-by-row geometry checks between 2 tables, which becomes very slow as data grows. With pre-powered spatial index category, there are 3 main parts. First, single-node spatial index join, so spatial joins no longer have to compare every pair of rows. Second, distributed broadcast spatial join, which is more efficient in cluster environments when a large table joins with a small spatial table. And third, more memory-efficient geometry handling, replacing full deserialization with streaming B-box action and reading straight directly from the eCadr. The related changes also removed spatial runtime filters from join planning and added correctness regression tests for spatial joins. On the lakehouse side, the most important update is Paimon catalog support, and it came from a community contributor. With it, Databend can directly read Paimon tables and also supports distributed writes without going through an extra intermediate path. For teams already building lakes on Paimon, this means they can connect Databend directly for analytics. Iceberg also received 2 improvements. One fixed preserved, making pushdown more complete. The other adds CI coverage for reading Iceberg variant metadata, improving compatibility assurance. You can see that Databend is gaining more ways to interact with the broader data ecosystem. Now let's look at data loading and export. Databend's import capabilities were already fairly complete, while export was relatively thinner. So these 2 months focused on filling out the inload side. First, multi-format, unload added arrow and org export formats, together with the existing formats. Copy into stage now covers most mainstream export needs. Second, arrow can now be used directly as a stage file format. This removes one conversion from the flow. The last improvement is very practical: source tracking during load. New metadata columns such as metadata file path, file base name, and file last modified make it much easier to investigate which file a row came from. And DJSON schema inference has also become more robust. These 2 months also added a set of small SQL improvements that make day-to-day work smoother. For example, Illinois Ike provides case insensitive pattern matching, so you no longer need to wrap things in lower yourself. Stream Backlog added an API and table function, making it easy to check how many changes are pending on a stream. Virtual columns now support materialized syntax is supported, reducing changes for SQL migrated from PostgreSQL. Time travel also gained a shortcut path. No check can locate snapshots directly, making the lookup faster. On the storage side, things are becoming both smarter and cleaner. Multi-insert supports distributed writes, so one statement writing to multiple tables can run in parallel across nodes. Clustering added depth percentile metric segmentation, making recluster lighter and reducing historical baggage. Vacuum 2 now deletes blocks incrementally, lowering peak overhead. A new parquet writer was introduced, and concurrent I/O operations now have an upper limit to prevent the storage layer from being overwhelmed by sudden bursts. Security was a less visible but very clear threat over these 2 months, focused on network boundaries and multi-tenant isolation. Both are areas that really matter in production. On network egress, Databend added endpoint, egress policy, and support for allow list mode, so queries can be explicitly restricted to external endpoints that are allowed, reducing the risk of data being written where it should not go. Stage path traversal protection also moved from settings to the config layer. On tenant isolation, several multi-tenant boundary issues were fixed, including tenant override in sessions, HTTP session isolation by tenant, and avoiding empty row caches. Connection information in logs and error messages is now more strongly redacted. On the operations side, the most interesting change is Lua transaction support in Databend. Lua scripts can now orchestrate transaction operations on Meta, and together with a monotonic clock and ordered execution, this raises the programmability of operations by a level. Under the hood, cleanup continues as well. Crate boundaries are becoming clearer, and Metabench now has more complete performance measurements. As mentioned earlier, this update includes 80 bug fixes. Reading the list alone may feel fragmented, but if we group them, the main themes are simple: do not crash, do not calculate wrong, and do not get stuck. First, do not crash. Fixes included Stack Overflow caused by deeply nested expressions and self-deadlock during runtime destruction. Once triggered, these issues can bring down an entire query, so they are high priority. Fixes cover nullable arrays in unnest, arithmetic overflow in date and timestamp operations, column shadowing in grouping sets, and equality hash joins incorrectly degrading into nested loops. These are all correctness edge cases being tightened one by one. Third, do not get stuck. Reclustered dead loops were fixed, and HEO row count determinism was guaranteed. Finally, cross-version upgrades are smoother now, with rollback compatibility restored for reading legacy bin code and cluster stats. Behind these 80 fixes, Databend is quietly becoming more reliable in exactly these areas. After all these individual capabilities, let's look at a real use case that ties them together. On Databend Cloud, building an automated cleaning pipeline for observability data generated by model evaluation. the data flow looks roughly like this. Model eval observability data first lands in S3 as JSON. A task periodically copies into new files into a raw table captures increments, and another task periodically consumes that stream, cleans and expands the raw JSON, and writes it into a clean table. In the first loading step, each observation is stored as a variant value, while the newly added stage metadata columns record which file the batch came from. In the second step, a stream is created on the raw table, so each cleaning run only processes newly arrived data. The third step is the core cleaning logic extracting nested fields from variables, flattening them into structured columns, using path access, typecasts, and lateral flatten to expand arrays, all directly in SQL. Once the pipeline is running, there is a very practical question. Is cleaning keeping up with incoming data? This is exactly where stream backlog fits. Query the stream to see how many changes are still unconsumed, and the backlog becomes immediately visible. If it keeps growing, the compute. So, the new stage, metadata columns, stream backlog, and Databend, long-standing strength in variant JSON processing, come together naturally in this pipeline. Finally, let's talk about something new currently in private beta Databend Cloud Agent. It is an AI assistant embedded directly in the Databend Cloud Console. Users describe what they want in natural language, and the agent can use 21 capability domains and around 110 tools to complete actions inside the console, such as querying data, managing clusters, troubleshooting builds, building data synchronization, and generating. It covers the full flow from asking a question to getting the task done. You no longer need to switch back and forth across multiple interfaces. Just describe clearly what you want to do. Cloud Agent is currently in private beta and will gradually open for trial later. Looking back at these 2 months, Databend's work can be summarized in one sentence. It continued to strengthen the stability required in production, represented by those 80 fixes, while also taking several outward steps in spatial analytics, optimizer statistics, and the lakehouse ecosystem. Spatial indexes moved from pruning to joins. The statistics module adopted KLL Countman Sketch, and Paimon was integrated through a community contribution. In the ecosystem, Bend SQL and Databend, JDBC also received supporting updates, making real-world integration smoother. Databend is an open project, and you are welcome to participate just like the contributor who brought in Paimon catalog this time. The official website is databend.com, the documentation is at docs, and the code is on GitHub under Databend Labs, Databend. Thanks for watching, and see you next time.